At the top of the last page, you're going to see that I've given you a reminder for 6 different rules of exponents. You might want to go ahead and pause the video and just check out those reminder statements. Now that you have those exponent rules in mind again, let's go ahead and check out the new item for this section. The idea that if a to the u is equal to a to the v, then u has to equal v. As you look at this statement, the first comment that I have here is that this works only if you have the same base on the left-hand side and the right-hand side. So if you didn't catch that when you read this the first time, you want to make a little note to yourself off to the left or circle the statement that I have on the handout to say this only works if you have the same base. So we have to have a on the left and a on the right. The other comment then is that this is actually just a different way of saying that this exponential function y equals a to the x is 1 to 1. So because exponential functions are 1 to 1, we can say that if a to the u is equal to a to the v, then u has to equal v. So we can use that then for problems like example 4. Example 4a then has 5 to the x is equal to 5 to the second. So remember once again, this rule from the top only works if we have the same base on the left-hand side and the right-hand side. So the first thing I need to do is just check what's the base on the left, what's the base on the right, and do we have the same base? Base on the left-hand side here is 5. The base on the right-hand side is 5. It's the same base. So because we have the same base on the left-hand side and the right-hand side, I can move forward with this rule. The only way that this exponential equation can be true is if the exponent on the left, x, is equal to the exponent on the right, 2. But now, if I step back, there's something special that just happened. Remember what it means to solve an equation? It means get x alone and x equals somebody at the end of the problem. That's exactly what we did. We got x equals somebody and the x is alone. So we just solved this equation. X has to equal 2. Now, as we move on to part B, you're going to notice that the base on the left-hand side is 2, but the base on the right-hand side is 8. That means we cannot use this rule from the top of the page yet. So what I have to do is make a decision. I can either move forward by rewriting both sides so that we're using the base from the left-hand side, or I can move forward and use the base from the right-hand side. Well, on this particular problem, the left-hand side is already written nicely as an exponential statement, so I'm just going to go ahead and leave the left-hand side as it is. I'm just going to bring it down as 2 to the x. So what that means then is that I've chosen the base on this problem to be 2. So I have a base of 2 on the left-hand side of the equation. I also need to have a base of 2 on the right-hand side. So that means I need to rewrite this right-hand side as 2 to some kind of power. Well, if you think about this for a bit, if I take 2 and multiply times itself 3 times, I'm going to get 8 back. So that means I can rewrite 8 as 2 to the 3rd power. So now that I've done this, I can now use this rule from the top of the page. I have the same base on the left-hand side and the right-hand side. If I have the same base on the left-hand side and the right-hand side, once again, the only way that this can work is if the exponents themselves are equal. So x from the left-hand side has to equal 3 from the right-hand side. And once again, that means we're done with that particular problem. We've solved that equation. Well, now as you look at part C, I can choose the base on the left, 5, or I can choose the base on the right, 1/5. I'm going to choose the base of 5. So once again, the left-hand side is already written in terms of that base. So I just need to write the right-hand side as 5 to a power. Well, if you think back to some of the other things we did earlier in this section, we talked about negative exponents. And remember that negative exponents move things. So 5 to the negative 1st power is equivalent to 1/5. So now that I know that, I have the same base on the left-hand side and the right-hand side. And because of that, I can use my property from up above. So 5 to a power equals 5 to a power. The only way that that can happen is if the exponent on the left-hand side is equal to the exponent on the right-hand side. That's a linear equation, and I can solve that linear equation. So to get the x completely alone, I need to subtract 3 from both sides. That means x has to equal -4. So the solution for our 3rd equation is x equals -4.